Hello, I am Marquis Johnson. My CRN is 10446 of Computer Concepts. And my first video, I will be doing binary problems, specifically converting hexadecimal to decimal. So for the first one, we got 7b. So what I was taught, and a simple way to do it, you split the 7 and the b into nibble bits, or I forgot the term for it, but basically you would take 1 through 8 bits for 7 and 1 through 8 bits for b. So, and because this is hexadecimal, we are using the A B C D E F rule, where A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So let's go through this. So for 7, for the first nibble, we want to add up. We want to turn on the bits that will add up to 7. So it will go 0. So from left to right, it goes 1, 2, 4, 8. So the two bits that add up to 7 is the 4, the 2, and the 1. Hold up, I gotta fix that real quick. The 4, 2, and the 1. That will equal 7. For the B, which is 11, you want to turn on the 8-bit, the 2-bit, and the 1-bit. 8 plus 2 plus 1 equals 11. So after that, after you got all the bits that need to be turned on, now you want to, from left to right, for both nibbles, you want to add up all the bits that are turned on. So when we do this, remember that the bits go from 1 to 128. So starting from right here all the way over here, it goes 1, 2, 4, 8, 16, 32, 64, 128. So adding all the bits that are turned on, we're going to add 64 plus 32 plus 8 plus 2 plus 1 will give us 123 in decimal. So let's go on to the next problem. We got E5. So same thing as before. 0. So we're going to take the bits for E. So E is 14. So the bits that add up to 14 is 8, 4, and 2. 8 plus 4 equals 12, plus 2 equals 14. For 5, the bits that add up to 5 will be 4 and 1. 4 plus 1 equals 5. After that, we do the exact same thing we did in problem 1. We go from left to right, and then we add up all the bits that are turned on. So 128 is turned on, 64 is turned on, 32 is turned on, 6 is not turned on. 4, my bad, I messed up on that one. It's actually 4. 4 plus 1. And that will equal, I forgot to add it. But let's figure that out. That will equal, sorry, I've stopped the video to change some things. So that will equal 229. So let's go on to the next one. 3a. I didn't put the addition at the bottom. I just wanted, now that we have an idea how it is, we could just do it by head. So 3a. So first, like we said, we take 3. What adds up to 3? The 1 and the 2-bit. So 1 for the, and then for what adds up to a, which is 10, is the 8 and the 2. So adding up all the bits that are turned on, which is 32, 16, 8, and 2, we get 58 in decimal. 66. So for 6, it will be the exact same. The nibble will be the exact same because, 6. So we will turn on the bit 4 and 2 for both of them. And then add up all the bits that are turned on, which will be 64 plus 32 plus 4 plus 2. And that will give us 102. Now we got 70, or 7-0. So for 7, it will be 4 plus 2 plus 1. But because there's a 0, no bits will be turned on for 0. So all we really got to do is add 64 plus 32 plus 16, which will give us 112. The sixth problem, 44, it's the same thing. but this time, oh no, I got that one right. So this time, we would turn on the fourth bit. The fourth bit, and then we will turn on the fourth bit for both of them, and then we will add the bits that are turned on. So it would be 64 plus 4, and that would give us 68. Now we got 24. So this one's actually very simple. We just turn on the 2-bit, and then we turn on the 4-bit for the second one. That would be 32 plus 4, and that would give us 36. Now for 8, now we got 2 letters. So A equals 10 and B equals 11. So we will turn for A, we will turn on the 8-bit and the 2-bit to equal 10. And for the B, we will turn on the 8-bit, the 2-bit, and the 1-bit. And so after adding all the bits that are turned on, which is 128 plus 32 plus 8 plus 2 and 1, that would give us 167. For number 9, E0, we got another 0. So for E is 14. So for E, it's we're gonna turn on the 8-bit, the 4-bit, and the 2-bit, and we won't turn on any bits for 0. So now all we gotta do is add 128 plus 64 plus 32, and that will equal 224. So for the last one, which is FF, all bits are turned on. All bits are turned on. So really, all we have to do is just add all the bits from 1 to 128. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that would give us 255. And that's it for binary. Next video, I will explain how to put together a program plan using the program life cycle.